This is Professor Urbis White. Today we'll be talking about correlation and regression. The first thing that I will talk about is linear regression, when we are trying to fit a line through a given set of data. Now we have paired data that we would like to find out the relationship between the two sets of paired data. So the regression equation, the linear regression equation, will be given by y hat equals b0 plus b1x. And the formulas, I didn't write them down. They are very lengthy. When you have them, they are very lengthy. It is very tedious to get those formulas and plug them in your calculator, using your calculator as a scientific calculator. So your option is to get the regression equation using your graphing calculator. So let's look at an example. I have a set of data, heights, and an interval. The question is, find the best predicted time of the interval after an eruption, given that the current eruption has a height of 100 feet. So we are talking about Old Faithful. So these are the heights of Old Faithful's eruptions. And these are the time intervals in minutes. So these are in feet, and these are in minutes. And we know that the heights and the time intervals are related. How do we find that out? We make a plot and see if there is some kind of relationship between the two sets of data. So this is what I will do. So I will show you how to generate a data plot, and then enter the height, and then enter the interval, and then see if there is any kind of pattern. So let's go to the calculator. Now I will enter the height data in L1 and the time interval data in L2, and I'll show you how to do that. Your calculator has the stat button, so push that, and you are going to push edit, and it will give you the columns. In L1, I will enter the height. So I will enter 140 feet and push down button, 110 feet, down button again, 125 feet, down button again, 120 feet, 140, again 120, 125, and 150. Imagine what this will be like when you have a lot of data points. Now I'm going to go to L2, and I will get the time interval between eruptions. When it's 140 feet, it's 92 minutes. Then I have 65 minutes, 72 minutes, 94 minutes, 83 minutes, 94 minutes again, 101 minutes, and 87 minutes. Now I do not know if these two things are related, so what I can do, I can go to stat plot and look at a scattered plot for that. So I will go to second stat plot, and I will turn on my plot by pushing enter and entering again, and that way the on button is blinking. And you can go to type, and the first one is simply your scatter plot. To select it, you just have to push enter. You have to tell your calculator where the X list is, and that's L1. You entered second L1. And for Y list, you have L2, second L2. So we're assuming the time interval is dependent upon the height of the eruption. So to make sure that you have the right zoom in place, you can go to zoom. This is a little trick that you can use. You can go down, and you can look at zoom stat, and it will go and pick the best zoom for you and push enter. And as you see your data, it looks like it is increasing. Okay, I'm not just looking at the goodness of it right now. We're just assuming that we want to pass a line through it, and this is the scatter plot that I have. Now, to get the linear regression line, what you need to do is you need to go to Stat, and you need to go to Test, and you need to go linear regression test, which is down there, and linear regression t-test. So that's option F. Push enter. And the X list, you have to tell where you put it. You put it in L1, and Y list is in L2. Do not touch the frequency. And you're actually doing a hypothesis testing. Row not equal to 1, always pick that one. And there's nothing to enter here. All you have to do is push calculate. When you push calculate, you will actually get the A, which is here, 54.267. And when you scroll down a little bit, 0.24646. So I'm going to write those down so that I do not forget it. So let's go back to the paper. So the calculator told me that y is a plus bx, and a is simply 54. I will take a couple of digits, 268, plus b 0.246x. Now, I'm going to go back to my calculator. What I will do is I will pick y. This is where I can enter a formula. So I will enter the formula for my regression line, which happens to be 54.268 plus 0.246 times x. And x is taken from that button of variables. When I go back to graph, let me go to stat plot. Oh, here we go. So it took a little while. So you can see your scatter plots, and you can see your line. Now, if you want to get more parameters related to that, you can go back and put down all these parameters. But what you can do, another thing is, like the question was, when x is 100, in other words, when x is 100 feet, what is the predicted time interval going to be? You can actually go and pick trace and go down with the down arrow. It's going to go straight to the line, and x value is right here. You can go to the left, and you see the values are changing. You're at 126, and you can go down all the way to 100 to get an idea of what's going to happen when you have 100. I'm at 110, 9, 7, 6, and so forth. One way is to do that and kind of estimate it. The other way is to go and change. Now, this is a good point. It did take the zoom stat because you are beyond this. What you can do, if you want to extend this thing, what you need to do is you need to change your window to include that value. And I'm looking for x equals 100. So I'm going to go and change my window. My x minimum is 106. I would like to get down to 99 or so. When I graph it, now this time it's going to go all the way down a little bit so I can include the 100. One way to get this either is to plug in into your equation, or you can go and use another feature of your calculator, which is second calculate. And the first button is value. When you push the value, that is asking what is the x value that you want to plug in. I would like to plug in 100. And when I push enter, it will go to that point, 100, and it will actually go and calculate the y. And when I go back to my data, it looks like I got this one wrong. It's probably was not 100 but 110 or so. So I will just change that. My calculator tells me that it is 78.9, which is about 79 minutes. Now, you may ask yourself whether or not it is a good idea to go beyond the data and get an estimate for something that you do not have data for. That's called extrapolation. You can extrapolate and do it, but take it with a grain of salt. You may not be accurate because your x values, the heights, are simply a lot higher than 100, and your smallest height is 110. So you are beyond the data point. You can predict it by extrapolation, but you have to make sure that you understand that that may not be a very good idea each time. Now let's go to the next example. What happens when you have a situation where you cannot pass a line and you have to pass another type of fit, and you have a couple of options, and those are all built into your calculator. So I would like to give you an example of that. Now let's assume I have a situation. I have an xy value. It doesn't matter what they are, but I have a paired data where I have x equals 1, 2, 3, 4, 5, 6. I try to make it very simple. And y values are 2, 4, 8, 16, 32, 64. So if you want to go in and plot those in your stat plot in the calculator, you'll see that passing a line through it may not be a good idea. So let's go and let's do that. So I'm going to go to Stat, Edit, and I already have data in there. So I'm going to go and erase it. So to erase that, you go up to L1 and clear, and go to L2, go up to L2 and clear. Now I'm going to enter the data that I saw. So x is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And your y is going to be put in L2. And that's going to be 2, 4, 8, 16. 2, 4, 8, 16, 32, and 64. I would like to see what that plot looks like. So I go to Stat Plot and turn the plot on. And you have to go to the Type to Scatter Plot. X-list is an L1, Y-list is an L2. Now I would like to go and zoom statistics so that it takes the best zoom for you. Zoom stat and enter. Now I have that line in there that I will take off. That is left over. To take off the line is you have to go back to Y and simply delete it, or you can make it inactive. You can enter. So when you push enter in there and it turns to white, that means you're not having that graph active. So I didn't want to erase it. I just make it inactive right now. Another way is to just clear it, and then you have that equation gone. So you can do it either way. So if you look at your graph again, if you pass the line through it, it doesn't look like it's going to fit, but this is a little bit curved. So you have to decide what you would like to try. Now, your options are going to be, you can pass a linear line, the quadratic, which is like this, a parabola. You can pass a logarithmic. Logarithmic is increasing with the concave down curve, so it's going to be like concave down like that. So your data doesn't look like that. Or you can have an exponential or power function. So that's the one increasing with the concave up curve. Concave up curve. So what you can do, you can try either one and see which one fits better. So I'm going to try the exponential right now. To get your calculator to remember that you have all these options in addition to linear regression, what you can do, you can go to catalog. So let me get out of here. I second quit and then clear this screen. I will go to catalog. The catalog is this lower button. You pick it up as second 0. And you are going to go down to something called diagnostic on. And this is under D. You can either push D or you can just scroll down. I'll just scroll down. And if you go in there, you have a diagnostic on. And let's pick enter. And it will give you that, and just enter it one more time. And it will say, yeah, it's done. What do you want to do? So we entered L1 and L2. Now I'm going to go back to Stat. This time I will go and select Calculate. Now if you go in there now, you're going to go and you'll see that you have a lot more. You had the linear regression, and look, you have the quadratic, which is 5, the cubic you can pass through, and then you have, here we go, power, and then exponential. So I'm going to just try the exponential just to show you that it works best with the exponential. So when you push enter, it's going to kind of think a little bit. And this one was a theoretical case, and it is giving you the formula, and it's giving you what R is, and R happens to be 100%. So that's a perfect fit. It doesn't happen in real life, but let's assume this happened in real life for some obscure reason. So I'll go back to my paper and I'll just copy this thing down and I'll put it in my calculator. So let's go back to my paper. So according to this, I have an A times B to the X power. A is simply 1 and B is 2 to the X power. So if I go and enter this in my calculator, it should fit perfectly. So let's go back to the calculator. If I go to graph, you just see those dots, and they are in squares. Now I'm going to go ahead and enter the formula by picking Y. And it's going to be 2 to the X. So that means 2 to the is that caret sign, X. And I will plot both the data points and my estimated the curve on the same graph. So push graph. And as you see, since it's 100% fit, it's going to go right through your data points. That doesn't always happen. So you have a lot of options to go and activate the diagnostic and do this on your own. This concludes this session about getting a linear regression line based on data and fitting a curve based on your guess of what the data will follow in terms of a power function or an exponential function. And you can do that, and you can actually activate your calculator and get those features in by just activating the diagnostic button from the catalog. And I showed you how to do that for one case.